One of the coolest things about science is how it can completely blow your mind and teach you that something that you thought you understood very well is completely and totally wrong. Take ordinary matter, the kind that makes up you and me and, well, everything around you. You probably think you have a pretty good idea how it works, don't you? For instance, you almost certainly know that it comes in 3 familiar varieties, specifically gas, liquid, and solid. Now, a science fan knows of other states of matter, but let's just stick with the most common ones. What I'm going to talk about is true of all 3 states of matter, but let's just talk about solids, as this is the form of matter that can best illustrate just how non-intuitive the quantum world is. So you know what it means to be solid. It means that something doesn't change its shape and you can't go through it. So, well, that's pretty straightforward. The science comes in when you remember that you also know that matter is made of atoms. Depending on how strong your science background is, you've probably seen pictures like these, with little balls representing the atoms. In solids, the atoms are all cozied up against one another. And that could easily be your mental picture of why solids are solid. In this basic idea, the atoms don't have much space between one another, and that's why you can't put your hand through them. That's why they're solid. So everything I've said is pretty true so far, but there is a problem. And the problem is when we remember that an atom is a tiny nucleus surrounded by a cloud of electrons. Basically, the atom is a little like a solar system with a solar nucleus and planetary electrons. And that means that the atom, like the solar system, is mostly empty space. Okay, so let's talk about the consequences of this solar system atom. Even if all atoms are nestled cozily adjacent to one another, the atoms themselves are basically just totally empty space. So just how empty are they, really? Tossing around some numbers, an atom is about 100,000 times larger than its nucleus. This means we can think of the nucleus as a tiny core with a very tiny electrons orbiting in a huge volume around the nucleus. Perhaps the easiest way to understand this is by way of analogy. Suppose we were able to somehow enlarge protons and neutrons to be the size of these BBs we see here in my hand. For concreteness, I'm using these BBs to represent the nucleus of a carbon atom. 6 protons and 6 neutrons form the nucleus of a carbon atom. Given that the carbon has 6 protons, it must also have 6 electrons. So if the protons are the size of BBs, how big is the atom? Well, the atom is about 100,000 times larger than the BBs, which means that the atom consists of 6 point-like electrons orbiting in a volume big enough to fill a football stadium. Now think about that. If an atom consists of a few BBs on the 50-yard line and 6 electrons zooming around in the volume of a football stadium, that means that the atom is almost entirely empty space. If we do the math, we find that, well, roughly speaking, the part of an atom that is occupied by matter is about 1/4,000,000th of the total volume. Basically, the first approximation, atoms are entirely empty. So if individual atoms are essentially empty space, then even if we pack the atoms tightly together, then matter is basically totally empty. So why is it that we can't put our hands through all matter? What is it that makes solids, well, solid? That is the next cool thing about matter. What makes matter solid is the electric fields that are both holding the electrons to the nucleus and also holding adjacent atoms together. Remember that the nucleus of an atom is positively charged, while the electrons are negatively charged. These charges set up electric fields which exert forces on each other. And, hijacking a word from science fiction, we have a term for this situation: force fields. So, even though an individual atom is essentially empty space, that space is actually filled up with force fields. And those force fields are also what holds atoms together. At the deepest level, all of matter is just made of force fields with a tiny sprinkling of particles. And that is what makes solids solid. It's not that matter that makes up the atoms, it's the force fields holding them together. What keeps me from falling through the earth or keeps me from walking through solid walls is the fact that I am made of force fields, and the force fields of the walls repel mine. So this is one of those epiphany moments in which you understand just how cool science really is. At the deepest and most fundamental level, you are nothing more than a bunch of empty space and force fields. This is a really bizarre way to think about matter, but it's totally accurate. And hopefully, once again, science has blown your mind.